Hey everyone, and welcome to RUBIN'S Mind Lab, where we break down the latest research into what it really means. Ever wonder if those super smart AI chatbots actually understand us? Or if they're just fancy word machines? Well, this new psychology research dives deep into that very question, and it gives us a really helpful way to think about these powerful tools. This paper points out that we often misunderstand what large language models or LLMs actually are. Think of them as the technology behind things like ChatGPT. We tend to fall into two traps. Either we think they're just simple autocomplete tools, like superpowered predictive text, or we start thinking they're basically tiny brains, maybe even proto-minds. Both of these ideas, the paper argues, are wrong because they miss crucial details about how these systems actually work and how they are used. The researchers call these simplified ideas folk theories, which are basically our everyday intuitive ways of understanding complicated things. They can be catchy slogans like just autocomplete or stochastic parrots, or more human-like descriptions like emergent agents. The problem is, these slogans often capture a small part of the truth but make us think that is the whole story. For example, calling it stochastic parrots highlights that it might just be repeating patterns from its training data, but it ignores how these models are actually used and improved in real-world applications. To get past these misunderstandings, the paper proposes a minimal working model. It is like a basic blueprint for how these LLM systems function. This model is built on four key distinctions. First, it separates the raw training of the model from how it is actually used in a product. Think of it like the difference between a raw ingredient and a finished meal. Second, it distinguishes between the huge amount of information the model learned during training and the specific answers it gives out at any one time. It is like the difference between all the books in a library and one specific sentence you might read. Third, it clarifies different types of memory LMS use, the information baked into their structure, the temporary memory of the current conversation, and any external memory like databases they might access. And fourth, it separates having the competence to do a task from having genuine agency or conscious intent like humans do. Using this model, the paper identifies 6 common misconceptions. Let's break them down. The first misconception is that LLMs are simply predicting the next word in a sentence. While it is true that at their core they are trained to do this, this description is incomplete when we look at how they are deployed. The paper explains that when LLMs are put into systems, meaning they are combined with tools or designed to interact with software, or have their output carefully controlled, their capabilities go far beyond just predicting the next token. For instance, they mention a system called GenetPT that uses LLMs with special tools for genetics. It performed much better than LLMs without these tools, showing that the surrounding system, not just the core prediction ability, is key to its competence. The takeaway here is that to understand what an LLM can do, you have to look at the entire system it is part of, not just the basic model. This next idea suggests that because LMS learn from vast amounts of text, their output will always be bland and average, like the average of the internet. The paper argues this isn't quite right. While LMS do learn from a distribution of data, they don't just spit out averages. The specific way they generate text through something called decoding policies, and how they are prompted can lead to very diverse and even unusual outputs. The paper gives examples of AI systems that, when used with search or other tools, can discover new mathematical ideas or create art that goes beyond typical human output. It is not that the model is inherently bland, it is often a choice in how we ask it questions and how we filter its responses. This is the idea that LLMs are just copying and pasting from what they've learned. The paper acknowledges that sometimes LLMs can reproduce exact phrases, which is a concern for things like copyright and privacy. However, it emphasizes that most of what LLMs produce isn't a direct copy. Instead, they combine and recombine patterns learned from many different sources to create new text. It is more like remixing than copying. The paper suggests that instead of assuming everything is a copy, we should ask if the output is truly verbatim or near verbatim. This is a common confusion in how we think about conversations with AI. On one hand, we might worry that every word we type is being permanently stored and remembered. On the other hand, we might think the AI has no memory at all, and each interaction is completely fresh. The paper clarifies that there are actually 3 types of memory involved. There is the parametric memory encoded in the model's weights. Then there is contextual memory, which is the conversation history that fits within the current window of what the AI can process at that moment. Finally, there is external memory, like databases or logs, that a product might use. The key is to understand where information is stored and how it is reused, rather than assuming a single, monolithic memory system. This refers to how LLMs are often adjusted after their initial training. Fine-tuning and RLHF, reinforcement learning from human feedback, are ways to make the AI more helpful, honest, and harmless. The misconception is that these are just like putting on a polite filter that can be easily removed, leaving a neutral core untouched. The paper explains that these processes actually change the model's core parameters, the very same ones that hold its knowledge and skills. It is not adding a separate mask, it is fundamentally reshaping the model. This means that these adjustments are not easily reversible, and they can involve trade-offs in what the AI can do or say. This is perhaps the biggest misconception, the one about whether AI understands things. We tend to swing between thinking LLMs are already thinking like us, with beliefs and intentions, or dismissing them as just mindless symbol manipulators that can't truly understand anything. The paper proposes a middle ground. It says LLMs show significant task competence. They can perform many tasks reliably and generalize well. They have a kind of functional understanding of information. However, they lack the embodied, conscious, human-like understanding that comes from having a body, experiencing the world, and having persistent goals and beliefs. So, instead of asking, does it understand? The better question is, what specific tasks can it reliably perform? So, what does all this mean? The paper argues that understanding these distinctions is crucial for how we evaluate AI capabilities, design AI systems, and create rules and policies around them. For evaluation, we need to look at the whole deployed system, not just the base model. For design, we need to be clear about how memory is handled and understand that fine. Tuning is a fundamental part of shaping AI behavior. For governance and public discussion, this framework helps us avoid the extremes of either dismissing AI as trivial or treating it as a sentient being with rights. It encourages us to focus on the concrete design choices and their implications. The paper even looks at how major publishers are writing their AI policies and finds that many of them fall into these same conceptual traps. For example, some policies suggest that AI-generated text is inherently less scientifically reliable, simply because it is AI or because the training data has a cutoff date. This overlooks how AI can be used with tools and verification systems to actually improve reliability. Other policies conflate different types of AI memory, leading to broad statements about data access that don't account for the specific ways data is stored and used in different AI products. The paper shows how clarifying these distinctions can lead to more precise and effective policies. Ultimately, this research provides us with a really useful toolkit. It helps us move beyond catchy but misleading slogans and think more precisely about what LLMs are, what they can do, and what their limitations are, by understanding the core distinctions between training and deployment, distribution and sample, different types of memory. And competence versus agency, you can have more informed discussions and make better decisions about these technologies that are increasingly shaping our world. It is not about whether AI has a mind, but about understanding the system's architecture, its behavior, and the conditions under which it operates. Now, for my take on this, I think this paper does a fantastic job of demystifying LLMs. The folk theories concept is really insightful because it explains why we so often get it wrong. We want simple explanations for complex things, and these slogans are just easier to grasp than the technical reality. The 4 distinctions provide a solid framework for cutting through the hype. One of the strengths is how it connects these conceptual distinctions to real-world implications, from evaluating AI performance to drafting policies. For example, the discussion on publisher policies shows how abstract ideas about AI can lead to ineffective or even misleading rules. A limitation, as with most research like this, is that the field of LLMs is moving incredibly fast. What is true today might be slightly different tomorrow. However, the fundamental distinctions the paper lays out are likely to remain relevant for a long time. In terms of real-world applications, this research is crucial for anyone developing, using, or regulating AI. It gives us the language and the concepts to be more precise. For developers, it means building more robust and transparent systems. For users, it means having more realistic expectations. For policymakers, it means creating more effective guidelines. Future research could build on this by applying this diagnostic framework to even more nuanced aspects of AI behavior, like creativity, or by developing specific tests to identify which distinctions are being conflated in different contexts. I am particularly interested to see how this framework can help us better understand the ethical implications of AI as it becomes even more integrated into our lives. What do you think? Does this framework help you understand LLMs better? Let me know in the comments below. And if you found this breakdown useful, Please give this video a thumbs up, subscribe to Rubin's Mind Lab for more science explained simply, and hit that notification bell so you don't miss our next exploration into the fascinating world of the mind. Thanks for watching.